Hi, my name is Apostolos Diokas, and I'm a lead software engineer at Uxma. At Uxma, we support our clients to create awesome software together with an excellent user experience. Did it ever happen to you that you started an app with the best intentions, had a great test coverage, but as soon as the app grew, it became harder and harder to maintain those tests and keep the build times low? Today, I want to talk to you about the best practices we learned on how to implement automated tests. Some words about the app we are working on. One of Uxma's biggest clients is the BSH. From the very first day, we are working together with BSH on the Home Connect app. With Home Connect, you can control your home appliances, from the washing machine to the oven, to the coffee maker, to the vacuum cleaner. The Home Connect app gives you access and control to all the appliance features at any time from anywhere. I personally am a part of the Home Connect's core team, and my main focus lies in iOS. Home Connect allows the user to control and connect to his household appliance and control them either through a cloud connection or directly through the local Wi-Fi network. We started developing this app around about 10 years ago. And from the beginning, we wanted to assure high quality and a short release cycle. In order to achieve this, we needed to have extensive automated tests, which would continuously check the app and be our guarantee that everything is working as planned. Probably most of you have seen the testing pyramids. There are more variations of the testing pyramid, but I will focus on this one, which has 4 different layers. The base layer consists of unit tests. Unit tests are cheap to write, run fast, and test one single unit at a time. The next layer consists out of integration tests, which test multiple units at a time. These tests are more cumbersome to write and run slightly slower. In the next layer are the end-to-end tests. They test the product from the perspective of the end user and are even harder to write and of course slower. In the top layer are the manual tests, where one or multiple testers need to check the application manually. These tests are by far the slowest and the most expensive. And of course, they are running outside of the CI/CD cycle. The pyramid also shows that each layer, which is below another, is bigger and wider than the above. Why? Because unit tests are the foundation. They should always be there and cover all the edge cases and scenarios. We should have plenty of integration tests, which test more complex scenarios and the cooperation of multiple units. End-to-end tests should also be there. They are slower and more expensive, but they are the only automated tests which test from the user's point of view. Manually testing should be done on scenarios which are impossible or almost impossible to test automated. Our test strategy was to have unit tests. We wrote unit tests for our database implementation, for the home appliance communication, and of course for our business logic. Soon, we had the idea that instead of testing every single unit, it would be much more efficient to have end-to-end UI tests. That way we could kill 3 birds with 1 stone. We would test the app from the user's perspective and all the business logic and communication with it. The UI tests were, at that point in time, easy to implement and quite fast, due to the single fact that the app was not so big yet. We also had written some home appliance simulator software which could perfectly simulate one or multiple home appliances. We use that in our UI tests to have end-to-end tests and test scenarios like pair a home appliance, send some commands to it, check if we are receiving messages from the home appliances. We were able to have end-to-end UI tests for complex scenarios. Log a user in, pair multiple home appliances, send some commands, start some programs, unpair the appliances again, and log the user out. With every additional feature, we wrote at least one new test. An issue was that for every test, the app needed to start. They went to the login screen, logged the user in, and all UI tests needed to go through these steps. In order to save time, some tests, instead of testing one scenario, tested multiple ones. Big mistake back then. The test time with every new feature, it grew, and we were forced to let the UI tests run outside of our CI/CD process. They were running continuously, and when they failed, some developer needed to find out what caused this fail. At that time, we were around about 6 developers in this project. Communication with the team was really good, and usually a failed test was fixed soon. At least at the beginning, this was the case. More code meant more tests. More tests meant longer build times. A full testing cycle soon needed more than 100 minutes. Also, flaky tests were appearing. A test is characterized as flaky when it does not fail consistently, but fails randomly. There are also 2 types of flaky tests. The good ones, where the same test fails occasionally, and the bad type, where different tests fail occasionally. We, of course, had the second type. In our case, sometimes the reason for flaky tests would be the network connection to the home appliance, or some connection issue with the backend. This gave us developers the excuse to just run the tests again. The tests, so we thought, would probably be successful next time. At some point, the tests were so flaky, it was almost impossible to run the tests successfully for more than 5 times in a row. From time to time, some brave developer would confront the flaky tests and fix them. A process which usually took quite a long time. One, because every test run needed at least 100 minutes. Imagine, try to fix something, then wait 100 minutes to see if the test run is successful, and then hope it will not fail again after 5 test runs. Some lessons we learned from that time back then. That the tests need to run fast. That the tests need to be a part of the CI/CD process. The tests should be deterministic. They should have always exactly the same result. One should take care of flaky tests immediately. And that shared stable. So tests should be completely independent from each other. Also, test results should be stable and repeatable. A change in our test strategy was necessary. So we stopped our UI tests, descoped them completely, and focused on unit integration tests. What unit integration tests did, they run much faster and are much more stable. Most importantly, what they did is they brought back our confidence in our test results. For quite a long time, this worked, and our app became more successful and popular. Our team got bigger, much bigger, and many features were added. With the new features, our code base grew, and it grew by a lot. And with the code base, the complexity of the code base grew too. The tests also did not get any simpler. and the time needed to run those tests multiplied. Our build and testing time grew from around about 20 minutes to over 45. Flaky tests appeared again. And after some time, flaky tests were so dominant that we lost our confidence in our tests again, completely. When we had a failed test, we were not sure if our changes caused it to fail or some other random error. What became common practice was that we developers did just rerun any failed tests until they were green. For a second time now, we need to do something. Refactor. And we choose two main actions. First one was we use clean architecture in order to have a better dependency management and separation of concerns. Clean architecture helped us to keep our units small and easily writable. For our developers, it now became much easier to write stable unit tests. Also, the code base became cleaner and much better maintainable. Second action was modularize the app. Split our app from one big monolith into smaller, easy maintainable modules. We decided to use a feature-based modularization and not a layer-based one. Features are separated now in different modules. Also, we separated all modules in 3 different categories. Feature modules, which contained separate features. The category 2, core modules, which contained business logic. And shared modules for our utilities. In order not to have cross-dependencies across our modules, feature modules are not allowed to know each other and can only know core and shared modules. Core modules cannot know each other and can only depend on shared modules. And shared modules, they may not depend on any other module. When we were splitting up the monolith, parts which had a good test coverage could easily be migrated into independent modules. And there was a high confidence that we did not introduce new bugs while doing so. Unit tests, which we wrote multiple years ago, saved us a lot of trouble by assuring that we did not do anything wrong while we were migrating. We migrated the whole database, its implementation, its logic, its entities in a matter of days. The existing unit tests showed us, by failing, the problems we were introducing when migrating, and we could fix those problems immediately. Modularization in clean architecture really boosted our ability to have good and stable tests. The scope of each module was limited, and therefore it was very easy to test. Because of the size of the modules, build and test times were also reduced. We were able to build and test multiple modules in parallel, and our overall test time dropped from 45 minutes to under 25. Also, flaky tests were drastically reduced. Modularization in clean architecture changed our way we tested the app. The confidence we have in our tests right now is much higher than any time in the past. Due to this confidence, stability, performance, and not constantly being frustrated with slow and flaky tests, developers started to write more and better tests again. Not only unit tests, but also UI tests on module level. those UI tests do not test the whole app, which will make them slow, but test just one module. To write UI tests, most of our teams use a tool from Lyft named Hema. They look much like unit tests, and the developers can easily write them and run them. They also run quite fast. The first video, the left video, is taken in slow motion. The second video shows the tests in real time. But we also wanted to have tests test the cooperation of multiple units, so-called integration tests. Before we dive in, some words about how do we handle our dependencies. If we want to test a class, we are injecting all its dependencies as mocks. Then we are able to stop these mocks and test all scenarios. In my example here, I have a use case named getInformation, which has one dependency, and this is the protocol information source. The use case returns the data struct name information, which is fetched from the source for the given identifier. Or it throws an error if the requested information was not found. In the unit test, we are initiating the class using information mock, which we can fully control and modify. We stop that with the necessary information to check that the function is throwing an error when the requested information is missing. In a different test, we would stop it with valid information for the requested identifier to check that the function is returning the correct information. Quite simple. Unit tests do a very, very good job to ensure that one specific class is run correctly. Unfortunately, a feature does not consist just of one class, but a combination of multiple classes and functions. Even one specific functionality can involve dozens of different classes. As an example, to start a home appliance, we need to firstly find this home appliance, check its status, eventually power it on. Okay, set the correct options to this appliance. Start the appliance, then check the result. Did the appliance start it, or do we have an error? We need to check that all the above things cooperate correctly, and the start appliance did finish successfully, or we logged an error if something failed. We needed a way to automatically check that a complete feature, which is using multiple units, is working correctly. Again, our modularization saved the day here. A few details now about how each module is structured. It consists of two main parts. The public API part, where we have just the public interface or protocols and no implementation at all. And the implementation part, where we have the implementation, and there we define as public only what really needs to be public, nothing more. This structure also helped us to maintain a quite good documentation about what each module is doing. Also, mocks and tests belong to each module. Each module now can have dependencies to other modules, exactly like one class can have dependencies to other classes. No difference there. The dependencies are injected into each module, very similar on how we inject dependencies into a class. When doing integration tests, instead of injecting the dependencies of a specific class, we mock and inject the dependencies of the whole module. By fully controlling the external dependencies, we are able to test the functionality of a module as a black box. If the module provides business logic without any UI, then those integration tests are written like regular unit tests. Now, if the module provides UI, then we use UI tests to check that the module as a whole behaves as expected. Those tests are, like unit tests, fast, because the scope is limited really to the scope of the module, and we do not run the whole app. Our main takeaways: if your app grows, do not hesitate to take drastic measures to improve your test and app quality. Even if these measures mean that you need to refactor a big part of your app. Divide and conquer. Do not try to test your whole monolith at once. Split it up and test each part thoroughly. Modularize. Modularization will improve your tests and speed up your build process. Random failing tests are not random. Take care of them as soon as possible. They will not magically disappear. And test on multiple levels. Have unit tests, have integration tests, have UI tests, and of course, have manual tests. Thank you all. I'll be awaiting your questions. And you can reach me either through Twitter or through LinkedIn. Thank you very much. So we have some question. When you have an app with no tests and you want to start, but have a limited time, would you start with UI tests? As the test longer scenarios, you can quickly cover the critical scenarios. Writing unit tests for a non-tested app is very consuming. Yes, unfortunately, we have been there. It does look like a good scenario. Look, I write 1, 2, 3 bigger tests which cover multiple things, and in the end, it really came back again and it bit us. We didn't have good experience with that. Because they are not scaling fast, and they also are not assuring that code which is below is clean. So we don't have other questions. So I guess thank you all.